Hey everyone! If I asked you to think about what you were doing last week or last year, it'd be pretty easy to picture, right? But what if I asked you to visualize the last 4.5 billion years, the entire history of Earth? Our human brains just aren't wired to understand a number of that massive. To put it into perspective, human history is just a tiny blink in the eye of time compared to how long Earth and life have been around. And that's why we're building a cosmic calendar.
If we squeeze all 4.5 billion years into a regular 12-month calendar, the numbers get a lot easier to wrap our heads around. But as you can see from my data table and the timeline graph, if we kept this calendar small, almost all the major events would be crowded together right at the very end. I actually made a separate page just for the month of December to be able to show all of these events without them being on top of each other. To actually see the distance between these milestones and to show you how long the planet actually went without us, we have to think big. That's why we're taking this calendar outside and spreading it across a 100-meter stretch. Before we take the tour, let me show you how I put this massive timeline together. First, I calculated the exact distances using Excel formulas. So on this scale, a single month is about 8.3 meters, and every single meter you see me walk represents a massive 46 million years. Next came the props. I used gardening stakes and zip ties to secure my events along with the cosmic calendar. Finally, I grabbed my measuring tape, headed out to my grandparents' backyard, and laid out the monthly and billion-year markers. Are you ready to see just how small our slice of history really is? Let's go take a walk through time.
Welcome to the very beginning of our journey. Right here at the starting line of our 100-meter cosmic calendar is January 1st. This marks the formation of Earth about 4.6 billion years ago. To put this scale into perspective for our SOS audience, our entire planet's history is stretched across this 100-meter stretch. If you can see right there. On this scale, a single month is about 8.3 meters, and every single meter you see me walk represents a massive 46 million years of deep time. Let's take our first few steps into January to see how a very young Earth started to take shape. All right, so right here, we've walked just over 4 meters from our starting line. We've already traveled 200 million years through time. We are at January 17th, which represents 4.4 billion years ago, the formation of the moon. Scientists think of Mars-sized objects smashed into the early Earth, blasting out a cloud of molten debris that eventually clumped together to form our moon. Back then, the moon was much closer to the Earth than it is today, making it look absolutely massive in the night sky. All right. Now, stepping forward to our next event, we've stepped forward into January 25th, or 4.3 billion years ago. Earth is finally starting to cool down. This is when the crust begins solidifying. Before this, Earth was just basically a wild, glowing ball of liquid magma. But by the last week of January in our calendar, just 6.5 meters from where we started, a hardened, rocky outer shell finally begins to form. This is the very first solid ground our planet ever had. Finally, we reached January 29th, about 4.25 billion years ago. We are now about 7.6 meters away from our starting point. At this point in time, impacts deliver simple organics. The early solar system was like a cosmic shooting gallery. Comets and meteors were constantly slamming into Earth, and they brought a very special delivery: water and basic carbon-based molecules. These simple organics are literally the raw ingredients, the building blocks needed for life to eventually spark later in the calendar. Now, look back at how far we've come through our first month's history. If you see all the way down there. And we still have over 92 meters of the calendar left to explore. Now, we come to February 1st. As we cross the 8.3 meter mark, we officially leave behind January and step into February. In terms of deep time, we are now cruising past 4.1 billion years ago. The planet is cooling, the oceans are filling up, and the stage is set for the next major phase in Earth's history. Now, the next event that we see, welcome to February 2nd in our cosmic calendar, roughly 4.2 billion years ago. We are just under 9 meters into our 100-meter track, and the planet is undergoing a massive transformation. The rains fill the oceans. After millions of years of volcanic eruptions and comet impacts delivering water vapor into the atmosphere, the Earth finally cooled down enough for the water to condense. It didn't just drizzle, it rained torrentially for thousands, possibly millions of years, creating the very first global oceans. If you were standing here 4.2 billion years ago, you'd be looking at a vast, endless blue world. Moving forward to February 15th, or 4.3 billion years ago, 4.03 billion years ago, we hit a milestone that geologists absolutely love, the oldest known rock. While Earth's crust started solidifying back in January, the planet was so chaotic that almost all of the original crust was destroyed and melted back down. However, at this 12.4 meter mark on our track, we find the age of the oldest intact rock ever discovered on Earth, the Acasta gneiss in northern Canada. This is the oldest piece of our planet's solid history that we can actually touch today. Finally, we end up at February 22nd, about 3.95 billion years ago, where the heavy bombardment ends. For the first 600 million years of Earth's existence, our planet was stuck in a brutal cosmic shooting gallery, constantly pelted down by giant asteroids and comets. But by late February on our calendar, just over 14 meters from our starting line, the solar system finally cleared out. This chaos stopped, the skies cleared, and the Earth's environment finally stabilized enough to set the stage for life to truly take over the planet. If you look back across the 14 meters we walked so far, you see exactly how long it took for Earth to simply settle down and get ready for action. Now, let's pause here. Let's pause here. We are at March 1st, but now looking back at the first 2 months on our calendar, January and February, you might wonder, not counting the creation of Earth itself, what was the most significant thing to happen? Personally, I think it's right here, going back to the formation of our moon. It's easy to think of the moon as just a pretty night light, but it was actually the ultimate unsung hero of our planet. When it gives a giant space rock smashed into Earth to create it, it didn't just give us a moon, it gave us stability. The moon acts like a gravitational anchor. Without it, Earth would wobble wildly on its axis, causing chaotic, extreme climate shifts that would make it almost impossible for advanced life to ever evolve. Plus, being so close back then, it generated massive ocean tides that churned up the chemical ingredients needed to kickstart life. So yeah, standing here just 4.3 meters into our 100-meter track, we are looking at the exact event that set the stage for everything else to come. Now, we're going back to March 1st. Welcome back to March 1st on our cosmic calendar. We are now exactly 16.1 meters into our 100-meter track, representing 3.686 billion years ago. The chaotic asteroid impacts have finally started to slow to a crawl, the oceans are stable, and the chemical stage is perfectly set for the most exciting chapter in Earth's history, the origin of life. So we're going to move just a little bit down. I want to draw attention to our first critical highlighted event here on March 2nd, the earliest evidence of life. This is roughly 3.85 billion years ago. Now, we don't have the actual fossilized bodies from this exact date, but we have something called isotopic markers. For an SOS analogy, think of this like waking up in the morning and finding a messy, empty plate with maple syrup streaks on the kitchen counter. You didn't actually see your roommate eat breakfast, but that specific chemical leftover is absolute proof that someone was there doing it. That's what scientists found in rocks from this era, a unique fingerprint of carbon-12 isotopes that only living organisms leave behind when they process energy. Life was officially eating breakfast on Earth just 16.3 meters into our track. All right, our next marker. We walked a good distance down the track to the 21.7 meter mark, landing on March 21st, 3.6 billion years ago. Happy birthday to us, because Earth is officially 1 billion years old. It took an entire billion years, nearly a quarter of our entire 100-meter track, to just transition from a molten ball of magma to a stable planet with oceans, a solid crust, and the first chemical traces of microscopic life. It puts into perspective just how slow and steady that planetary evolution really is. This brings us to our next highlighted major milestone on March 29th, the oldest intact fossils, dating back to 3.5 billion years ago. Unlike the chemical traces we found a few meters back, here at the 23.9 meter mark, we have physical concrete proof of life. These fossils are called stromatolites, which were built built by massive colonies of single-celled organisms. To use a great SOS analogy, imagine a crowded music festival where thousands of people throw down sticky plastic cups layer after layer onto the muddy ground. By the end of the weekend, you're left with a giant, hard, layered mound of trash. Stromatolites are essentially ancient fossilized bacterial trash mounds. Microscopic cyanobacteria trapped layers of settlement and glued them together with sticky slime, creating rock structures that survived for billions of years. This is our definitive receipt that life had officially taken over the oceans. Now, here's a mind-blowing cosmic comparison for you. Right around this exact time on our calendar, 3.5 billion years ago, the oceans and abundant surface water on Mars would have likely dried up and disappeared forever. So if life had emerged on Mars and evolved at the exact same pace as it did on Earth, well, what would Martian life have looked like right before the planet dried out? Well, don't picture little green men or sci-fi monsters. If you dipped a cup into the ancient Martian ocean, life would have been entirely microscopic and single-celled. The waters would be a soup of primitive anaerobic microbes that didn't even breathe oxygen. The most exciting thing you would see would be along those shallow Martian beaches, colonies of bacteria trapping sediment to build sticky, slimy, layered mounds, just like the stromatolites that we're standing next to now at our 23.9 meter mark. Mars was a living microscopic world right up until its clock ran out. Now, we have reached April 1st. As we step across the 24.6 meter mark, we officially enter the month of April, representing 3.465 billion years ago. The planet was quiet on the macro scale, but beneath the waves of the global ocean, those early single-celled organisms we talked about are thriving and slowly altering the chemistry of the planet. Now we reach the first of my personal events. I want to pause right here at the 25 meter mark because this represents April 5th, which just happens to be my birthday. At this point on the calendar, we are roughly 3.415 billion years ago. So what was Earth like on my birthday? Well, you wouldn't want to blow out any candles here because there was still no oxygen to breathe. The planet was a vast alien water world with a hazy carbon dioxide-rich sky. Volcanic islands were poking through the oceans, and the very first microcontinents were just beginning to cluster together. It was a wild, hot, and completely primitive world. Definitely a fixer-upper, but it's amazing to see what the planet would have looked like exactly 1/4 of the way through our calendar. All right, now we walk a little bit to May 1st. All right, we've got a lot of ground to cover, so let's walk all the way to our 32.1 meter mark. We have officially cruised into May 1st, which represents 3.09 billion years ago. We are nearly a third of the way through our 100-meter track, and the Earth is continuing its slow and steady evolution. Just a few steps into May, on May 8th, exactly 3 billion years ago, we hit a silent savior of an event, the oldest record of a magnetic field. Scientists studying ancient rocks in South Africa found microscopic magnetic particles locked into place from this exact time. This proves that the Earth's liquid iron core was sloshing around enough to generate a strong global magnetic shield. For our SOS audience, this shield is the only reason we're alive today. It acts like a giant cosmic force field, protecting the atmosphere and early life from being completely fried and stripped away by harsh solar radiation. All right, and we're walking a little bit further to June 1st. Welcome to June 1st on our cosmic calendar. We are now exactly 4.3 meters into our 100-meter track, representing 2.7 billion years ago. And right on the first day of the month, life hits a massive upgrade, the first eukaryotes. Up until now, all life on Earth was made of super simple prokaryotes, basically free-floating genetic material. But eukaryotes are cells that are finally evolved to a protective nucleus to store their DNA, along with specialized internal parts. They are still single-celled at this point, but this structural leap is the absolute genetic foundation needed for all complex multicellular life, including plants, animals, and us to eventually evolve. All right, we've reached our next birthday. Stepping up to the 43.5 meter mark, we hit June 9th on the calendar, or 2.6 billion years ago. Take a look down the track. We have made it. We are approaching the halfway point of our 100 meter calendar. And it's incredible to realize that for an entire 2 billion years, the Earth has been completely ruled by nothing but microscopic single-celled organisms. The cosmic clock is ticking. Planet-wide changes take immense amounts of time. All right. Now, I want to draw your attention to a critical game-changing highlight event right here on June 17th. Atmospheric ocean grows to 1 to 2%. This is about 2.5 billion years ago, sitting at our 45.7 meter mark. Now, 1 to 2% oxygen might not sound like a lot compared to the 21% we breathe today, but back then, it was a total planetary crisis known as the Great Oxidation Event. For our SOS analogy, imagine you're in a massive group chat planning a weekend party. A couple of people start spamming the chat with memes. At first, it's fine. The chat absorbs it, and you can still see the actual plans. But suddenly, everyone starts spamming memes at the exact same time. The chat gets completely flooded, it crashes your phone, and the original plans are totally ruined. That's exactly what is happening to the Earth's atmosphere. Early photosynthetic bacteria have been quietly pumping out oxygen as a waste product for hundreds of millions of years, and the ocean successfully absorbed it all like a sponge. But right here at the 45.7 meter mark, the oceans couldn't hold it anymore. The oxygen's completely flooded out into the atmosphere all at once. For the dominant microbes of the time, oxygen was actually a toxic poison, causing one of the biggest mass ghostings or mass extinctions in Earth history. But it completely reset our atmosphere and paved the way for oxygen-breathing life like us to eventually enter the chat. All right, finally we walked to the 47.8 meter mark, landing on June 25th, 2.4 billion years ago. And things are getting chilly because we've reached the oldest evidence of a snowball Earth. Remember that oxygen that just flooded the atmosphere? It reacted with the planet's atmospheric methane, a powerful greenhouse gas, and practically wiped it out. Without that methane blanket to trap heat, Earth experienced a catastrophic global ice age. Glaciers stretched from the poles all the way to the equator, turning our planet into a giant frozen cosmic snowball. Life was forced to retreat deep underwater near volcanic vents just to survive the freeze. All right, as we cross the 49.5 meter mark, we officially entered the month of July, representing 2.325 billion years ago. We are now practically at the halfway point of our entire 100 meter track. Geologically, Earth is entering a period called the Boring Billion. The planet's surface is relatively stable, the oceans are full of oxygen-producing microbes, and life is quietly evolving behind the scenes, setting the structural foundation for everything to come. And we walk. All right, now we reach August 1st. We've got a lot of physical ground here, so let's walk all the way to the 58.1 meter mark, which brings us to August 1st, or 1.93 billion years ago. Take a look back down the track. You can see here. Yep. Take a look back down the track. We are well past the halfway mark of our calendar, and yet, if you look around the planet at this point in time, there are still no plants, no animals, and no trees. Earth is still an alien world dominated entirely by a microscopic scum in the oceans. Stepping up to the 65.2 meter mark, we've hit August 27th on our calendar. If I can get this to stay. August 27th on our calendar. Representing 1.6 billion years ago. And it is time for another massive milestone. The Earth is officially 3 billion years old. Think about that. We have walked nearly 2/3 of our 100 meter track just to reach this birthday. It is a fantastic reminder for our SOS audience of just how much time Earth spent simply preparing the stage, filtering the atmosphere, and letting single-celled life master the basics before complex life could ever show up. Now we just move a little bit down to September 1st. Just a few more steps brings us to the 66.6 meter mark, crossing the boundary into September 1st, or 1.52 4.35 billion years ago. We are entering the final third of our cosmic calendar. The planetary foundations are rock solid, the atmosphere is changing, and the cosmic clock is quietly ticking closer and closer to the explosion of visible complex life that is waiting for us in the months ahead. Crossing the 74.8 meter mark means we officially made it to October 1st, representing 1.16 billion years ago. We are well into the final quarter of our track. For the longest time, Earth has been quiet, microscopic world, but the pace is finally about to pick up. At the 80.4 meter mark, we hit October 2nd on the calendar, 90 million years ago, and life finally teams up. This is when multicellular life emerges. Instead of single cells floating around doing their own thing, cells finally figured out how to stick together, communicate, and divide up chores. These early multicellular organisms were incredibly simple. Think ancestors of modern sea sponges, but it's the official starting point for all complex bodies. Moving forward to the 83.1 meter mark, we cross into November 1st, or 775 million years ago. We are deep into the final stretch of our calendar, and the planet is about to throw one last frozen curveball at life. All right. On November 10th, roughly 650 million years ago, at our 85.8 meter mark, we hit the last snowball Earth. For the final time in global history, runaway ice sheets completely encased the globe from pole to pole. It was the ultimate survival test for those brand new multicellular organisms, forcing them to adapt or perish in a world of pure ice. All right, just a few steps later, at the 86.9 meter mark, it is November 14th, 60 million years ago, and Earth is officially 4 billion years old. Look back at how much track we've covered. Crazy, right? 86 entire meters of our 100-meter calendar are behind us. Up to this exact point, everything on Earth has been soft, slow, and mostly microscopic. But look ahead, because we are about the final 13 meters of our track are about to go absolutely wild. All right. I want to draw your attention to a massive game-changing highlight event right here on November 19th, the Cambrian explosion of life, about 542 million years ago. For an SOS analogy, imagine a major video game that has been stuck in a boring text-only beta testing phase for years. Suddenly, the developers drop a massive overnight update. All at once, the game gets full 4K graphics, open world maps, armored vehicles, weapon upgrades, and a complex factions fighting against each other. That overnight update is exactly what happened here at the 88.2 meter mark. In a geological blink of an eye, life exploded in diversity. Organisms didn't just crawl, they grew eyes, hard armor shells, sharp teeth, claws, and complex brains. This is the moment nature invented active predators and prey, completely rewriting the rules of the ocean and giving rise to the major animal groups we know today. All right, so let's pause here for a fascinating cosmic what if. Scientists estimate that the oceans on Venus completely evaporated between 500 million and 1 billion years ago. If life on Venus evolved at the exact same pace as Earth, look at what the planet lost when it dried up. If its oceans vanished 1 billion years ago, back around the October 5th mark, Venus would have only harbored simple slime and basic multicellular algae. But if Venus held onto its water until 500 million years ago, it would have reached the peak of the Cambrian explosion right here in late November. Venusian oceans would have been teeming with highly complex life, everything from armored, scuttling trilobites with compound eyes to primitive jawless fish and free-floating jellyfish. It was a fully realized, complex marine world right up until it suffered the ultimate runaway greenhouse effect. All right, so next we have our first fish. Welcome to November 24th on our cosmic calendar, or roughly 480 million years ago. We are sitting at the 89.6 meter mark, and the oceans are officially getting some backbone. This is the era of the first fish. These weren't like the fish we catch today. They were jawless, armored creatures that vacuumed up food from the ocean floor. But this moment is massive because it marks the rise of the first true vertebrates on Earth, the distant ancestors of every animal with a spine. All right, so this brings us to my second personal event. I want to draw your attention to a critical geological milestone right here on November 26th, the deposition of Kentucky limestone, which happened 450 million years ago. For an SOS analogy, imagine a busy campus coffee shop over a long semester. Thousands of students drop plastic straw wrappers on the floor every day. If nobody ever swept up the floor, those wrappers would pile up, get stomped on by thousands of feet, and eventually compressed into a solid, thick plastic mat and covering the entire room. That is exactly how this limestone formed. Back then, North America was actually sitting near the equator, covered by a warm, shallow tropical ocean teeming with shelled marine life. As those billions of tiny creatures died, their calcium-rich shells piled up on the ocean floor for millions of years. The weight of the ocean compressed those wrappers, quote unquote, into massive, dense layers of rock. Today, this exact limestone layer is what naturally filters the groundwater in Kentucky, making it famous for bourbon and horse racing. And it's the exact same rock layer that carved out Mammoth Cave, which we'll see later in my calendar. All right, so next, just a tiny step later on November 27th, 440 million years ago, the planet hits a brutal wall, the end Ordovician mass extinction. A sudden severe ice age caused sea levels to plummet and oceans to cool rapidly. It was devastating. In a geological heartbeat, a staggering 85% of all marine species were completely wiped off the planet. It was a massive reset button for Earth's biosphere, proving just how fragile the balance of life can be. All right. Life bounces back fast though. By November 29th, or 420 million years ago, at our 90.9 meter mark, we witnessed a major migration, arthropods on land. Tired of the chaotic oceans, the distant ancestors of modern insects, spiders, and centipedes became the first creatures to brave dry land. They had to evolve tough outer shells to keep from drying out in the sun, making them the ultimate terrestrial pioneers. All right. Ooh. No. All right. Our next event. Finally, we close out the month at the 91.3 meter mark, landing on November 30th, 400 million years ago. Take another deep breath with me because atmospheric oxygen nears present levels. Thanks to the early land plants finally spreading across the continents, oxygen levels surged right up to the 21% concentration we enjoy today. As we prepared to step into November for the final 9 meters of our track, the planet is fully terraformed, oxygenated, and perfectly primed for the age of land animals and dinosaurs, and eventually, us. All right. December 1st. All right. Welcome to December 1st on our cosmic calendar, or 385 million years ago. We are now in the final 9 meters of our 100 meter track. The year is coming to a close, but the pace of evolution is absolutely sprinting. Up until now, the continents have been mostly quiet, but December is the month where land truly comes alive. All right, so we've reached December 2nd, which is about 375 million years ago, and we have found that our vertebrates are on land. So this means that we have animals with backbones actually on land and taking up life. Right here in the next, right here at the 91.8 meter mark, we hit a double header on December 2nd, 375 million years ago. Oh. Go back. Right here at the 91.8 meter mark, we hit a double header on December 2nd. So these both are together, December 2nd. This is when pioneering four-legged fish-like creatures, our incredibly distant ancestors, officially hauled themselves out of the water and began adapting to life on shore. But right as they moved in, the planet threw a major curveball, the late Devonian mass extinction. Runaway environmental changes likely caused a drop in ocean ocean oxygen levels struck the marine world, wiping out roughly 75% of all species. Talk about a stressful move-in day for those first land animals. Next, on December 3rd, life pushed through the crisis. By December 3rd, or 360 million years ago, at our 92.2 meter mark, nature dropped a revolutionary botanical upgrade, the first seed plants. Before this, plants relied on water to transport their spores, meaning they were stuck living near swamps. But seeds allowed plants to protect their offsprings and send them deep inland, triggering a massive green explosion that coated the continents in the world's very first true forests. Next, I want to draw your attention to the next major highlighted milestone right here on December 6th, the formation of the Appalachian Mountains, about 325 million years ago. Today, we think of the Appalachians as weathered, gentle rolling hills. But for an SOS analogy, imagine a smooth, flat rug laid out on a hardwood floor. If you walk across the room and aggressively kick the edge of that rug, the fabric is going to slam together, buckle, and fold up into steep, towering ridges. That's exactly what happened here at the 92.9 meter mark. The ancient tectonic plates of North America and Africa collided at full speed. The immense pressure buckled Earth's crust, thrusting it upward into a jagged, towering mountain range that was originally as massive and majestic as the modern Himalayas. All right, so next. This brings us directly to our next highlighted milestone on December 9th, the formation of the Kentucky coal beds, which happened 299 million years ago. For an SOS analogy, think about a busy campus print lab where the recycling bins are completely overflowing. Students keep throwing thousands of sheets of scrap paper into a giant packed pile. Because it is buried so deep under new paper, no one can get there to sort or shred it. It just kind of sits there, getting heavily compressed over the whole school year into a dense, solid block of paper. This is exactly how coal is formed. Back then, the region was a massive, hot, swampy jungle covered in giant ancient trees. When those trees died, they fell into the stagnant ocean-poor swamp water, which completely stopped bacteria from rotting them down. For millions of years, layers of mud and more dead trees piled on top, acting like a giant planetary trash compactor. It squeezed out all of the water and left behind the dense, carbon-rich coal beds that sit beneath Kentucky today. All right. Finally, we step up to December 10th, or 280 million years ago, for the formation of supercontinent Pangaea. For those crashing tectonic plates that built the mountains didn't stop there. All of the Earth's separate land masses finally slammed together into one giant unified supercontinent, surrounded by a single massive global ocean. Look back at our track. We are nearly 94 meters into our 100-meter calendar. This world is completely connected, fully forested, and completely set up for the age of the dinosaurs. All right. Now I want to draw your attention to our next to a catastrophic planet-altering highlight event right here on December 12th, the end Permian mass extinction, which struck 250 million years ago. The scientists call this the Great Dying because it's the closest life on Earth has ever come to being completely erased. For an SOS analogy, imagine a massive university campus where a freak power surge blows out the electricity, the Wi-Fi, the plumbing, and the air conditioning all at once, right in the middle of finals week. The campus becomes totally unlivable, and a staggering 95% of their students pack up their bags, drop out, and leave forever. That's exactly how the broken planet was at the 94.6 meter mark. Colossal volcanic eruptions in Siberia flooded the atmosphere with greenhouse gases, triggering runaway global warming, acid rain, and suffocating stagnant oceans. It wiped out nearly 96% of the marine life and 70% of land animals. It was the ultimate baseline of reset for Earth's history. But life is stubborn. Moving forward to the 95.2 meter mark on December 15th, 220 million years ago, the empty spaces left by the Great Dying are finally filled by two iconic new groups, early mammals and dinosaurs. While the first mammals were tiny shrew-like creatures hiding in the shadows, the dinosaurs were getting ready to step up and completely dominate the land for the next several days of our calendar. All right. So these are actually together. Okay. Just a few steps later, at the 95.7 meter mark, we hit another double whammy on December 16th, 200 million years ago. First, the supercontinent Pangea breaks up as tectonic forces pull the giant landmass apart, opening up the early Atlantic Ocean. This geological breakup triggered massive volcanic activity, resulting in the Jurassic mass extinction, which claimed about 80% of all species. Luckily for the dinosaurs, they cruised right through this crisis and used the split continents to spread across the globe. Stepping forward to the 97.2 meter mark, it is December 22nd, 130 million years ago, and the world gets a splash of color, the earliest flowering plants. Before this, the forests were just boring shades of green ferns and pine trees. The evolution of flowers and sweet fruits introduced a brilliant new partnership with insects and animals for pollination, completely changing the aesthetics and ecosystems of the land. All right, and this is where it gets a little chaotic. Finally, we walk up to the 98.6 meter mark, landing on December 26th, 66 million years ago. And this day, the music died for the dinosaurs, the end Cretaceous mass extinction. A city-sized asteroid slammed into the Gulf of Mexico, unleashing global wildfires, tsunamis, and a thick blanket of dust that blocked out the sun for years. This sudden cosmic winter wiped out 75% of all species, including all non-avian dinosaurs. Look at our track. We are less than 1.5 meters away from the very end of our 100-meter calendar, and the board has just been cleared to make room for the rise of mammals, and eventually us. With the dinosaurs out of the picture, the age of the mammals kicks into overdrive. Right here at the 98.7 meter mark, December 27th, or 60 million years ago, we see the rise of early primates. These small tree-dwelling mammals evolved better vision and grasping hands, starting the long evolutionary branch that eventually leads directly to us. All right, so we have first hominids and Grand Canyon forms. Now we have to slow down because the scale of time is getting incredibly compressed. I am just standing 13 centimeters away from the absolute end of our 100-meter track, and we have finally reached the afternoon of New Year's Eve, December 31st. At 12:34 p.m. on the calendar 6 million years ago, powerful rivers began cutting through the rock to trigger the Grand Canyon forming. Just an hour and a half later on our clock, at 2:05 p.m., 5.2 million years ago, the first hominids emerged, with early human ancestors splitting away from chimpanzees and taking their first upright steps. I want to draw your attention to our last major highlighted milestone happening at 4:22 p.m. on New Year's Eve, the carving of Mammoth Cave, which started 4 million years ago. Remember that massive layer of Kentucky limestone we talked about back on November 26th? The one formed by billions of compressed prehistoric seashells? Well, here at the 99.91 meter mark, water finally started to hollow it out. For the SOS analogy, imagine a giant solid block of hard sugar sitting on a counter. If you take an eyedropper and slowly drip warm water onto the exact same spot day after day, the water is going to dissolve channels and carve out deep, hidden Swiss cheese pockets right through the middle of the block. That is exactly how Mammoth Cave was made. Slightly acidic rainwater trickled down into the cracks of that ancient limestone over millions of years, slowly dissolving the rock from the inside out to create the longest, most mind-blowing underground cave labyrinth in the world today. Now, to put our scale of our calendar into perspective, let's look at the gap between the day the dinosaurs vanished and the moment modern humans showed up. On our cosmic timeline, exactly 5 days passed between the asteroid impact on the morning of December 26th and our late arrival on New Year's Eve. Now look down at the ground with me. On our 100-meter track, that entire 66 million year explosion of mammal evolution, everything from early primates to the woolly mammoths, takes up a physical distance of just 1.39 meters. This little hop, skip, and a jump from the age of the reptiles standing right next to us now. All right, now you can kind of see it. This brings us directly to our final highlight event, happening at exactly 11:42 p.m. and 52 seconds, the appearance of modern Homo sapiens. This is 150,000 years ago, and it takes up just the last 3.3 millimeters of our entire 100-meter calendar. For our SOS analogy to help you grasp this insane scale, imagine watching a massive, epic 3-hour Hollywood blockbuster movie. The lights are down, the plot has been unfolding for hours, the action is crazy, and you are gripped. Humans don't even show up until the last 1/10 of a second before the credits roll. Everything we consider human history is crammed into the literal blink of an eye at the absolute end of this track. But our story almost ended as soon as it started. Less than 10 minutes later on the cosmic clock at 11:51, 75,000 years ago, humans nearly go extinct. It was triggered by a catastrophic super eruption of the Toba volcano, which plunged the planet into a volcanic winter. It decimated ecosystems and crashed the global human population down to just a few thousand surviving individuals. We came incredibly close to being just another short-lived fossil layer on this track. We survived. We made it. And as time raced forward, at 11:59 and 46 seconds, just 14 seconds before midnight, ancient Greek astronomers looked up at the stars and began mapping the cosmos, living just 0.04 millimeters from the end. And finally, boom, midnight strikes. Present day. Happy New Year. Whoop. Look back down at the full expanse of this 100-meter layout. It took automated stellar shields, planetary bombardment, oxygen crises, global ice ages, and millions of years of microscopic evolution just to clear the path for a few final millimeters where you and I exist today. It shows you just how precious, rare, and deeply historic our timeline really is. Thank you for taking this cosmic journey with me. Now, let's tackle an awesome cosmic thought experiment. Suppose astronomers find an Earth-like planet orbiting a sun-like star, and they determine that it's exactly 1 billion years old. If life evolved there just like it did on Earth, what would we expect to find? To answer that, we have to walk all the way back to the 23.5 meter mark of our track, landing on March 26th. At this stage, you can completely forget about finding alien forests, animals, or even basic jellyfish. A 1 billion year old planet is still in its absolute infancy. The only life you would find here is completely invisible to the naked eye. Primitive, single-celled, microscopic bacteria drifting in the oceans. The most advanced thing on the planet would be slimy, rock-like mounds of trapped sediment built by colonies of blue-green algae, known as stromatolites. It's a completely microscopic world. But, plot twist, what if astronomers realized they made a math mistake? And one of their sharp students corrects it to find that the planet was actually 3 billion years old. If life evolved just like it did on Earth, our expectations changed completely. We have to fast forward all the way to the 65.8 meter mark on our track, landing us at June 21st, right at the summer solstice. 2 billion extra years makes a massive geological difference. While you still won't find any plants or animals walking around on the surface, life has upgraded significantly beneath the waves. This is the era of the first eukaryotes. Instead of just simple bacteria, the oceans are now home to a much larger, more complex, single-celled organisms that have protected DNA inside a nucleus. They've even figured out how to replicate sexually, which is the ultimate evolutionary engine. It's still a microscopic world, but the genetic blueprint for all complex future life, including us, is officially up and running.